Welcome, ladies and gentlemen. Today we're going to talk about some basic matrix operations. In this video, we're going to go for the three very basic things that you can do with matrices, which is just add them together, scalar multiplication, and some basic equation solving. The first thing I want to show you is how to add two matrices together. And the way this works is you need two matrices that are the same size, and you basically correspond each position to the corresponding position. So A corresponds to E, B corresponds to F, and so on. And you add those positions together. So it's important that you understand where the relative positions of each one are. The general rule of thumb, which can be seen on the very first slide here, although very complicated with an infinitely long matrix, that's the general rule, but generally we don't talk about matrices that are that large. So here's an example of the rule for a 2 by 2 matrix being added to another 2 by 2 matrix. Similarly, this works the same for subtraction. Again, you need matrices of the same size, but the corresponding positions, you just evaluate it the way you normally would with subtraction, but only subtracting the terms that are in the same relative positions, top right, bottom right, that sort of thing. So in this case, this is just driving home that point that you need two matrices that are of the same size. So however many rows or however many columns it has, it just needs to be identical. The size must be identical to the one that you're adding to. So these ones, you could either call it a 2 by 4 or a 4 by 2, but I have two of them that are the exact same dimensions, same number of rows, same number of columns, and you can totally perform that addition. But even if you say turn one sideways and you make a 2 by 4 a 4 by 2 or vice versa, you cannot perform that addition because the positions, the relative positions, don't line up. On this screen you'll see two example problems that I'd like you to pause the video and actually work out on paper to see if you can get the correct solution. If you do so correctly, this first one, all you do is you take, say, the top left, and add them together. So negative 5 plus 9 is 4. 0 plus 6 is 6, negative 1 plus 1 is 0, and so on. And you do that for every relative position in the matrix. So again, 8 plus 0 is 8, and so on and so forth. Over here, this is a subtraction problem. If you didn't get that one right, try this one again. And the correct answer to this, or at least a partial correct answer to this, again, just subtract the relative positions, negative 5 minus a negative 4, so the double negative comes into play, so we're actually adding a 4, and so on and so forth. You get negative 3, 6, and 0. But then I threw in some variables here, so you need to know how to handle that. And it's exactly the same way you would in a normal equation or an expression, and you just write it as x minus 6, and that x minus 6 is kind of viewed, you don't have to write the parentheses, but it helps you segregate those two terms from the term to the left of it. The next thing to discuss is scalar multiplication. Scalar multiplication with matrices is super easy. Basically, it works the same exact way as the distributive property, except you may have more than just 2 or 3 things to distribute it to. So that scalar e, that number on the outside of the matrix, applies to every element inside the matrix. So you would take e times a, e times b, e times c, and e times c, like so. Here's an example problem. Again, why don't you pause the video and try it yourself. And if you do that correctly, 2 times all the elements inside the matrix, or a negative 2 I should say, negative 2 times negative 3 is positive 6, times 0 is 0, times 1 is negative 2, and times 4 is negative 8. Now these two tricks that we've learned, addition, or I suppose 3 tricks technically, addition, subtraction, and multiplication, along with the idea of variables being thrown into a matrix, can be all combined into something a little more complicated. So this is a demonstration of one matrix being scalar multiplied by a number 5 and then added to another matrix of the same size, so it will work, and getting this answer over here. And your challenge for a problem like this would be to solve for each variable. So get a value for x, get a value for y, and get a value for z. Now to do that, basically you have to write an individual equation for each variable. Now let's go for the x right here, just because it comes first in the alphabet, and you'll notice that x is in the upper left hand corner. Well, that means that this x is going to be the result of adding 5 to this position times 5. So we only have to look at, there's a whole bunch of numbers on the screen, but you only have to pay attention to basically 4 items, the x, the 5, the -3, and of course the scalar multiplier out there. You put all that information together, and the trick here is that you have to be able to write an equation for you to solve. The equations will be easy, but you have to be able to write the correct equation. So in this case, it's 5 times -3 plus 5 should equal x. And then obviously just some simple evaluation there to get a value for x. If you have a variable in a different spot though, notice that the scalar multiplier applies to the 4y minus 1 and then is equal to -6. So you should be able to write an equation that looks like that. Solve it. It's a linear equation, very easy to do, and you get an answer of y is -1/4 or 0.25. Why don't you pause the video right here and write and solve an equation for the variable z. If you do that correctly, you're looking at the bottom left numbers the whole way. You're taking 5 times 1 minus z is equal to -2. Subtract 5 from both sides, multiply through with the -1, and you'll arrive at your answer of +7. That's the end of this lesson. I'll see you next time.